Hey everybody, it's Coach Gear making a video for you to start off the new year. Happy 2016 to everybody. Hopefully you had a good break and we can get the second half of the year started off and have a good second half of the year, getting ready for testing and all that stuff. So we're going to start out. Our first video of the year is on writing linear equations from situations, graphs, and tables. So we're going to start out with just a few little notes here, not much, but just something to get you back in the swing of what we were doing before we left for break. And we're going to be writing linear equations. The first thing we're going to do is based on a situation, which is like a real life thing happening. And we're just going to start out with the notes here. So first, when writing a linear equation in the form, and just want to write this down, y equals mx plus or minus b. And of course the m is our slope. That could be a negative also, but we don't usually put that in front of the m. But that's what's called slope-intercept form. Okay, so we want to write that up here. Slope-intercept form, so that you know what that is when you see it. And this is just how we write equations when we have the slope and the y-intercept. Again, the slope is the m, and the y-intercept, for some crazy reason, is a b. Okay, so when we're writing a linear equation in this form from a real-life situation, that means it just tells us a little bit of a story, and we got to figure out the equation. There are two things that you want to look for. The first one is the input variable. Input variable. This is the amount that's going to be changing throughout the situation. It's usually like the number of miles you drive, the number of minutes, the hourly cost of something. And there's a word you usually want to look for, and I want you to write this out to the side. This is a big key when you're looking for this, is per. Miles per hour. The miles is what you're talking about. The cost per dollar, you're talking about the cost. Okay, so the word per is a really important word when we're doing these. This is the number that will go in front of the x. Now again, remember the number in front of the x, that m, is also what we call our slope. Okay, so the input variable that we're going to be locating is also what the slope is. And this is usually, again, like I just said, an hourly cost or the number of minutes, and it's something you can input lots of different numbers in for. The second thing to look for is the information that is only going to happen once in the situation. And this is our y-intercept. And again, the parenthesis part here is just the letter B, which we use for the y-intercept. Okay? And again, one of the ways I told my students, the way to remember that it's a letter B is it's either above the origin, okay, above the origin, or below the origin, above or below. It's got B's in it, so maybe that might help you with this weird thing about a B meaning y-intercept. Again, this is the one-time fee or something like that. It might be the amount on a gift card. And again, this is something that will only happen once. And it's going to be the y-intercept of our graph. Once you have these two things, when you have the y-intercept and you have the slope, well then writing linear equations is pretty easy. So we're going to start off with our first situation here. It says Mike pays $15 per month. Again, look for that word right there, per month. That should kind of give it away. To be a member at the gym. And he pays $3 every time he goes to the gym. So this is the one that's going to be changing. Okay? 15 per month is only going to happen the one time. Okay? This is the one that's going to change. So sometimes you see that per word, you got to make sure you're reading it all, because just because it says per here does not mean that's the slope. So you got to also understand the situation. Sometimes that takes just reading the question more than once or twice. Sometimes you got to three read it, is what I say. Read it, reread it, read it if you got to. Okay, so we're going to write an equation to find his monthly cost based on how many times he goes to the gym. And again, we're going to write it in this form, y equals mx plus or minus b. So it's always going to start like this, y equals. Now, the amount that's going to change every time is this 3, okay? Every time he goes to the gym, it's going to be $3. 3. So this is the slope, or the input variable, $3 every time he goes, $3 per time that he goes. And then the number at the back that's that one-time fee. He only pays that once per month, that $15. Okay, so if you read through this, the Y is the amount he's paying, and that is 3 times how many times he visits that month, plus the $15 fee for being a member. Okay, so again, when we talk about this, we're doing Y. We're finding out how much it costs, this Y side. Okay, so if he becomes a member and never goes that month, well, guess what? He still has to pay that $15. They're not going to let you be a member and then just say, well, we'll only charge you if you show up. No, he's paying $15, and then he shows up if he wants to. So this is our first point. Again, that plus 15, that's our y-intercept, okay? Now, we're going to go by, let's see. Let's say he actually went to the gym 20 times that month. So here's our 20. So $20, 20 visits times $3 every visit is $60, plus the 15 for being a member means that for 20 visits, it would cost him $75. So there's our second point on the graph, and our graph would look something like this. And then anywhere on here that he wanted to see, how much it would cost him if he went 8 times to the gym, he would go up here and go, okay, that's about $40-something. If I went 16 times. Now, if he went more than 20, which in a month would be pretty good, he'd have to maybe, extend his graph out a little bit more, but that's the basic idea. Okay, the second one. Monique gets a $100 gift card to use at the coffee shop, and every time she goes there, it costs her $4. Write an equation to find out how much she will have left on her card based on how many times she goes to the coffee shop. So again, she's got $100 on her card. That's that one-time fee, or that's, in this case, it's just an amount on a card. Okay, that's not going to change from the beginning, but every time she spends $4, every time she goes to the coffee shop, this amount's going to decrease in this case. So we know at the back it's going to say plus 100. Again, that's the amount on her gift card. Okay, but again, every time she goes, she's spending $4, and that's why we wrote that negative in front of the 4, because she's spending $4 every time she goes to the coffee shop. Okay, now it might make more sense to write it like this at the beginning. You'd say, okay, she's got $100 on her card, and she spends $4 every time she goes. Okay, this might make a little more sense, but we want to write it in that slope-intercept form. This part here, we want to move to the front, and then this 100, which even though we don't see it, we know that's a positive, we put that at the back. Okay? So now let's just graph this real quick. Again, she starts out with that $100 on her card, and every time she goes to the coffee shop, she's spending $4. So if you did a little quick math in your head, you know that she could go to the coffee shop exactly 25 times before she'd run out of money on that card. So there would be our starting point. After 25 visits, she'd be down at 0. And there would be our graph, and we could look anywhere on there. She could say, all right, after 10 visits, how much would I have? Well, I'd have about $57 or whatever, $58, whatever that might be after that many visits. Actually, it's exactly 60, to be honest with you. 10 visits, $40, 100 minus 40, 60. So that would be that point right there. And you could find anywhere on there. Okay, our last one. You call a plumber to fix your sink. He tells you he charges a service fee, again, listen to that fee of $70, and that's just to show up at your house. He's not going to come out and look at your house, your plumbing for free, and then not get paid for it. That's why people that do business like that will charge you a fee just to show up, because they don't want to work for nothing. So he tells you it's going to cost $70 just for me to show up at your house, and then after that, it's $20 for every hour that I work. So we're going to write an equation to find out how much it will cost to get your sink fixed based on how many hours he will be there. So again, the one-time fee, that's that number at the back, that's the $70 that he's charging you. That one time, just once. The thing that's going to change is the $20 per hour that he's going to charge you while he's working. Hopefully it won't take too long, but you might want to know how much it's going to cost for 3 or 4 hours if it's going to take that long. So again, we come over here to our graph. Our first point is the 70. Now, my graph is going up by 20s here, so you got to find that spot between 60 and 80, because that's exactly 70. Okay. Then for 1 hour, it'd be $90. So here's 1 hour Here's 90. Because again, you still paid that $70 once, but that $20 for that 1 hour, so that's 90 altogether. If it was 2 hours, it'd be 2 times 20, which is 40, plus again, that's 70 that you paid at the beginning. That's 110. So 2 hours, 110. And as you can see, we have a straight line. Again, linear is what this means when it's straight like this. Now, it's not proportional. Remember, we talked about what proportional means. Doesn't go through 0, 0, and that's why you got all these plus or whatever, sometimes minus. I don't have any with minus on this, but those numbers there tells you it's not proportional because it does not go through 0, 0. Okay, let's flip over to the back. As I rest my arm, you probably see the camera shaking a little bit. Ooh, arm gets tired at 10 minutes of holding up the camera. Okay, now to write an equation from a graph, the process is almost the same based on the two things you need to find. First, you find the y-intercept. And again, in parentheses, we're writing down the letter B, just so we remember that better. And then we're going to use 2 points this time to find the slope, which again is our m. We also might want to put that this is our input variable. It's both. It's the slope and the input variable. Now, the way we're going to have to do this when we have points is we're going to have to use that form we did where it's y, and we use numbers down here just to kind of tell you that you use 2 different y numbers. It's really, I just say y minus y and x minus x, but that's how we're going to have to find the slope. Again, if these were proportional lines, we just would do y over x, but they're not. They don't go through 0, 0, so that's when we got to do y minus y and x minus x. Okay, so we look at our first example. Now, the first part's pretty easy. We're going to write down y equals, and then we're going to look for that point on the y-axis here. Okay, there's your y-axis, plus 20, so our first point is at positive 20. We know there's going to be an x right here. Now all we have to do is find the slope. Now, there's 2 ways to do this. You could do rise over run. That's totally okay. Or you could use these 2 points to find out where or what the slope is by doing y minus y and x minus x. So this point here is the point 0, 20. And this point here is the point 10 and 40. Okay, 10 over, 40 up. Okay, so if we're doing y minus y, again, our y's are our second numbers in our coordinates here, our points here. So we're going to do y minus y because this is just the easiest way to go. So I'm going to do 40 minus 20 on the top. And then I started with the 40 and went to 20 by subtracting. Now I got to do 10 minus 0 on the bottom. Got to go the same way. So then 40 minus 20 is 20. 10 minus 0 is 10. And 20 divided by 10 is 2. So that tells us our input variable or our slope. I said that really funny. It's not a slope. It's slope. Slope is 2. Now, if this was the situation, I wrote these on purpose. I made this similar to the one we had at the beginning. So here's what this would mean. If Mike went to the gym where he paid $20 a month to be a member, and then it was $2 every time he visited. Okay, so that's what that graph would look like. Okay, next one. Similar to the one about the coffee shop, except this time she's buying lunch. But again, the first thing we're going to do is write down y equals something x plus or minus b. Well, that first number is 50. Okay? That's how much this person has on that card. So 50. And now the slope goes